This is task 3 of tutorial 12, and we are given a differential equation here that's y prime is equal to x times y. With the initial condition y0 is equal to 1, which means our x0 is 0 and y0 is 1. We have to use the Runge fourth order method RK4 to determine the approximation of y at x is equal to 0.4, and we have to use the step size of 0.1 here and calculate the value of y at 0.4. So let's start working with this. We have the differential equation, which is x times y. The initial condition y0 is equal to 1. And we have to find out y at x is equal to 0.4. Our value of h is 0.1 here. So our equations for the Runge method are yi plus 1 is equal to yi plus 1 over 6 times k1 plus 2 times k2 plus 2 times k3 plus k4 times h. And what we can do is that we can replace the value h here by 0.1. So that will give us the equation that we need to solve here. So I just replace the value of h that we already know here, and then k1 is equal to f of xi yi. So we can say that k1 is equal to the function f x y is this one here, x times y. So I can replace the x by xi and the y by yi here. So let me write it again. So the function x comma y is this function here, which is x times y. So what I'm doing here is just replacing the value here, x and y, by xi and yi. So we'll get xi times yi. And that is the formula for k1. So here we have the formula for yi plus 1. For k2, our formula is f of xi plus half times h comma yi plus 1/2 times k1 times h. So if you replace the value of h now by, so we can replace here the value of h by 0.1. So we have yi plus 1/2 times k1 times 0.1. And then that will look like this one here. So we'll have xi plus 1/2 times 0.1 is 0.05, and comma, we'll have here yi plus 1/2 times 0.1 is again 0.05 times k1 here. So those are the values of x and y for us. So we can just say that k2 is in for the function we have, like, it is the value of the at the point where x is this one here and y is this one here. So we'll just multiply x times y for the function. So we have xi plus 0.05 here times yi plus 0.05 times k1. So that's the function, or the points for k2. And now for k3, is the value of the function at xi plus 1/2 times h, comma, yi plus 1/2 times k2 times h. So here we'll have, if we replace the values, so we'll have xi plus 1/2 times 0.1 plus yi plus 1/2 times k2 times 0.1. So that could be finally written as the x value here times the y value. So the x is xi plus 1/2 times 0.1 is 0.05 times y value, which is yi. So here it's not a plus but a comma. So we have here yi plus 0.05 times k2. So that's the formula for k3. And now we look at k4. So it's the value at the point where the function is xi plus h, comma, yi plus k3 times h. So now it will be xi plus 0.1, which is h, yi plus k3 times 0.1. So k4 is the function at the point xi plus 0.1 and yi plus k3 times 0.1. So the function is x times y, so we'll take this here as the x and this here as the y. So x is xi plus 0.1 times y, which is yi plus k3 times 0.1. So that will be the formula we'll take for k4. Now I'll write them all again down here. So for k1, we have this one here. For k2, we have this one here. For k3, we got this equation here. k4, that's k4, and now finally we'll take for y I plus 1. Okay, so that's what we'll solve now each time to get the values at every step. So now when I is equal to 0, x0 is equal to 0, that's given to us, y0 is equal to 1, and our h is equal to 0.1. And we have to find out the values of k1, k2, k3, and k4. So I'll just try to bring the formulas back again here. So now here we'll have x0 times, because x0 times y0, so that will be x0 is 0 times y0 is 1, which is equal to 0. And then here we'll have xi, or x0 plus 0.05, so x0 is 0, 0 plus 0.05 will be 0.05 times y0 plus 0.05 times k1, which is above. Here we have k1 value as 0, so k1 will be 0 here. 0 times 0.05 is 0, 0 plus y0, which is 1, is 1, so 0 plus 1 is 1 here, and that will give us 0.05. Now for k3, we have here the values x. Now here x0 plus 0.05 will be 0.05. So for all of these xi's here, we have x0 to be taken. For all of the yi, we will be taking y0, and so on. So here y0 plus 0.05 times k2, so k2 value is here, we have 0.05, so you can say we have y0, which is 1 plus 0.05 times k2, that's again 0.05, and this gives us the value 0.0501. Now here we have x0, which is 0, 0 plus 0.1 is 0.1 times, we have y0, that's 1, 1 plus k3, that's 0.0501 times 0.1, and that gives us the value 0.1005. And then we have now to calculate the y1. So y1 will be y0, that's 1 plus 1 over 6 times k1, which we got as 0, plus k2, that we got as 0.05, plus k3, that's 0.0501, plus k4. Okay, I'm supposed to multiply here by 2. So here we'll have 2 times k2, which is 0.05, plus 2 times k3, that's 0.0501, plus we have k4, that's 0.1005, and times we have the h, which is 0.1, and this gives us that y1 is equal to 1.0050. Okay, now let's go ahead and work out for when I is equal to 1. x1 is, we have x0 plus I times h, so x0 is 0, 0 plus I is 1 here, times h is 0.1, so x1 is 1.1, 0.1 here. So that's x1, and y1 we just calculated already, which was here, that's 1.0050. So we have here 1.0050, and now we'll again solve it for all the equations here. So for K1 we have, this time we'll have x1 times y1. So we'll take all x1 and y1 for all xi here and yi. So now we have here x1 is 0.1 times, we have y1, that's 1.0050, which will be equal to 0.1005. Now for K2, we have here x1 plus, so x1 is 0.1 plus 0.05. Here we have 0.1 plus 0.05 times y1, which is 1.0050 plus, sorry, no, bracket here. So we have plus 0.05 times K1, which is 0.1005, and that will give us the value. Before I write the value, I'll just shift this a bit more towards the left. So here we'll get the value as 0.1515. Now we'll have to calculate for this one here, where we have xi is, or x1 is 0.1 plus 0.05 times, we have y1 1.0050 plus 0.05 times K2, and the value of K2 is 0.1515. This gives us the value 0.1519. Now calculating K4, we have again x1 is 0.1 plus 0.1 times y1, which is 1.0050 plus, we have the K3 times, so K3 we just calculated was 0.1519 times 0.1 here, and this gives us the value 0.2040. Now we have to calculate the value for y2. So y2 will be y1 here, which is 1.0050 plus 1/6 times K1, that's 0.1005 plus 2 times K2, which is 0.1515 plus 2 times K3, which is 0.1519, plus we have 0.2040, and that gives us the value for y2 as 1.0202. That's the value for y2. Now we'll go ahead and calculate now for y3. So we'll take I is equal to the values that are above it. So for I is equal to 2 now, and x2 and y2. So I is equal to 2 and I is equal to 2, x2 2 is x1, which is 0.1, plus h, which is 0.1. So you have 0.2 x2 now. y2, we just calculated it. It was 1.0202, and that's it. So let's go ahead and again bring the formula back here and start our calculations. So here now we have x2 times y2, so 0.2 times 1.0202, that gives us the value 0.2040. And then for K2 we'll have here x2, which is 0.2 plus 0.05 times we have y2, that's 1.0202 plus 0.05 times K1, that we got as 0.2040, and this will give us the value 0.25. Maybe I'll write it down so I don't congest it here. So this will give us the value 0.2576. Now for K3, we have here xi or x2, which is 0.2 plus 0.05 times we have y2, which is again 1.0202 plus 0.05 times K2, which is 0.2576, and that gives us a value 0.2583. Now for K4, we have x2 plus 0.1 times y1, which is 1.0202 plus we have K3 that we just got 0.2583 times 0.1, and this gives us the value 0.3138. Now for y3, we have here y2, which is 1.0202 plus 1 over 6 times K1, 0.2040 plus 2 times K2, 0.2576 plus 2 times K3, 0.2583 plus 0.3138 times 0.1. So we can say y3 is equal to 1.0460. Now we'll go ahead and calculate for y4, and we'll use here. So why am I going ahead and calculating y2, y3, y4 is because here when I calculated y1, this was for the x value, (0.1). Now this one here is for the y at 0.2, and This one here is for y at 0.3. So we need to go ahead and calculate the value for y at 0.4. So for that, we have now I is equal to 3, x3 is equal to x2 plus h, which is 0.4, comma y3 that we just got here is 1.0460. Okay, here I did a mistake. So here it should be 0.2 plus 0.1, that's 0.3, and y3 is 1.0460. Now we go ahead and bring all the formulas back here again. And here we have x2 times y2. So we'll have x2, or sorry, not 2 but 3 here now. So x3 times y3, we have 0.3 times 1.0460. So that gives us the value for k1 as 0.3138. And then we have for k2 xi, so x3 that's 0.3 plus 0.05 times y3 that's 1.0460 plus 0.05 times k1 0.3138, and that is equal to 0.3716. For this one here we have x3 is 0.3 plus 0.05 times we have y3 which is 1.0460 plus 0.05 times k2, so the value that we just got here, 3716, and this gives us the value 0.3726. Now calculating k4, we have here xi, that's 0.3 plus 0.1 times y3 1.0460 plus k3, that's 0.3726 times 0.1, and that gives us the value 0.4333. Now calculating y4, we have y3 which is 1.0460 plus 1 over 6 times k1 0.3138 plus 2 times 0.3716 plus 2 times 0.3726 plus 0.4333, and that gives us y4 approximately equal to 1.0833. So that's the approximate value of y at x is equal to 0.4. Now we could draw a table to make it look more clear. So here we'll have the values for I, xi, k1, k2, k3, k4, and yi. So when I is equal to 0, x0 is 0 and y0 is 1. And then we have I is equal to 1, x1 is 0.1. That's adding the step size edge. Then I is equal to 2, we have 0.2, I is equal to 3, and we have 0.3, and when I is equal to 4, we have 0.4 here. Now for k1, we got the value at first here as 0, then 0.05, 0.0501, 0.1005, 1.00509, and here we got 0.1005, 0.1515 here, and then we had 0.1519 and 0.2040, 1.0202, and here we got 0.2040, 0.2576, 0.2583, and 0.3138 here, and y4 was, or y3 is 1.0460, and here we got 0.3138, 0.3716, 0.3726, and 0.4333, 1.0833. So you can see that at x is equal to 0.4, the value of y is 1.0833. So the value of y at x is equal to 0.4 that we are searching in this question here is approximately equal to 1.0833 up to 4 decimal places. And that's the end of task 3.